Welcome to the shop. I'm continuing to make the 750 parts for NQALHA Production Run 4. So better get going. Today I'm going to be trying something different. This is, I kind of haven't quite finished all the complex parts yet. I have one or two of the more complex ones left, but today I'm going to be making some simple parts, some small parts. And unfortunately, because the machine takes so long to do a tool change, even the small, simple parts take longer than I'd like. So I'm trying something new today that I've never tried. It's based on a known trusted tool path, but it's a new variation. I'm going to be trying to machine these parts two at a time by putting one on one side of the vise and the other on the other side of the vise. And I also made up a special tooling plate over here that has two part positions. So hopefully, if this all works, and I see no reason why it shouldn't, I'll be able to run basically once the pipeline gets filled, I'll be able to run 4 parts in the same load cycle. So this is, like I said, it's based on a known trusted tool path, but it's modified and it's new, and gonna go through the standard checks that I always do, running in single step mode, making sure everything looks sane before committing to letting the machine go on its own. I've got everything set up. I've got the tools loaded. I've got the 0 set using the Heimer indicator and the Tormach electronic tool setter. If you're interested in how setup and tool loading works, my earlier videos, I think did episode 1 and 2, go into great detail showing how the machine is set up and how the Heimer is used. But for this operation, it's very similar to one of my standard operations, except there's one small difference. Instead of setting the part 0 at the top of the blank, I set it on the ledge of the soft jaws, and I'm using special soft jaws that have a 240 ledge, so I can machine my 250 thick part. 250, that's a 1/4 inch for all of you who don't speak decimal, because I'm going to be taking a tiny bit of material off the surface, and I don't want the cutter to booger up my soft jaws. My regular soft jaws have, I think it's a 350 thousandths deep ledge, because most of the material that I use is 3/8 and half material. So in this case, there's 2 reasons that I put the 0 on the bottom of the part. Well, actually, 1 reason, but it ends up having 2 ramifications. The extruded material, even though its nominal size is 1/4 inch, well, sometimes it's maybe 1,000th over, which is still surprisingly good accuracy for the extrusion process. If you've ever watched extrusion, it's amazing, and I've designed extruded parts and talked to extruders. It's amazing how accurate the extrusion can be made. And if you watch it being made, you'll think, oh, that can never be accurate. But it is relatively accurate. When I'm, okay, this part, I want it to rotate freely. It's going to have a socket, I'm making all sorts of mistakes in today's video. It's going to have a shoulder screw going through a 1/4 inch hole, and then the shoulder fits up against the mating part. And a shoulder screw is fairly precisely made. And so if your material is 251 and you tighten down your shoulder screw, it's going to bind. So I machine off a little bit of material using the bottom of the part as reference, so I get a controlled thickness, which also has the side effect of producing a little boss on the surface where the bearings are clamped. A bearing, a ball bearing, typically has a flat face where the inner race and the outer race are the same thickness. And so if you just machine a flat piece of metal and tap a hole through it and screw a bearing down, the outer race will bind. So I get the clearance to make sure that the shoulder screw doesn't bind, and I get the clearance with the little boss to make sure that the bearing doesn't bind, all in one operation using the same tool. So that was a long-winded explanation. And here comes the tool. 3/8 Lakeshore carbide, solid carbide, 3 flute. Looks like it's stopping in the right place. Yep. It's hard to, with a very, very small amount of material being removed, it's hard to see with the machine running and the coolant on. So yes, I believe that is correct. So let's go ahead and run this part of the cycle at full speed. Yeah, it's doing the right thing, but it's not as optimized as I'd like it to be. So I'll probably go back to the CAD room and eliminate some of those rapid motions. Do everything on the left side at the same time, everything on the right side at the same time. At least I don't have to do a tool change. So here comes a 1/4 inch through hole. Single block. Looks like it's stopping in the right place. Looks like the proper depth and the proper peck cycle, 2500 RPM, 10 inches per minute, fast peck. All is looking well. Next operation is going to be a couple of 832 tapped holes. In the case of these very simple parts, the tool change takes longer than making the part. Stopping in the right place, pre-feed validated, feed height validated, 5140 RPM, 10 inches per minute, fast peck, and it looks like it's doing a very, very nice peck cycle, properly ejecting the chips. No rat nest buildup on the tool. Tormach tool changer is behaving reliably again. A couple of days ago I had a real problem with it. It just didn't want to play nice. But for the last couple of days, after cleaning and adjustment, it appears to be working correctly. So, once again, flood coolant doesn't work with this setup because the flood coolant just hits the body of the Tormach compression tension tap holder, and the flood coolant really doesn't work as well as Tap Magic for aluminum. Tap Magic for aluminum really is magic. It's correct because it's a through hole, but I believe it's tapping too deep, which isn't a problem, but I'm going to go back as I fix that other problem. I'm going to go back and fix this one too. So, first operation of the gang milling has been accomplished successfully, and here's what the, kind of hard to move my hand around, get the camera in focus. So there's what the little guy looks like with its little bosses, and the bosses are only like 15 thousandths tall. They're not really much, but they do prevent the bearing from binding. So off to the CAD room. Well, that took a little longer than I thought it would, but everything in machine work takes longer than I think. I guess I'm just too optimistic when I imagine how long something's going to take. So, having made some changes, gonna treat it like it was a new toolpath again. It's oh so easy. Okay, looking good, looking good. When things go wrong in 3-axis CNC, okay, there we go. They can often go wrong. Oh. Completely wrong. Totally, completely wrong. So, oh. Ain't this fun? Am I having fun yet? I don't know. Bobcat strikes again. It just, for who knows what random reason, just decided to, oh, your last operation was done with tool number 3. I'm going to switch to tool number 9. I don't know. I love CNC, I love computers. I spent my working life as a software engineer, but software can make you crazy. And that is correct. Just a bit of a philosophical comment while the machine is crunching away. It's very common, especially in large companies, to separate, very finely separate specialists. And so you'll have the designer of the machine, the engineer of the machine, then you'll have somebody else, and maybe even 2 or 3 designers and 2 or 3 engineers working together. And then the guy that creates the tool path is different from the guy that sets up the CNC machine. And then it finally, when it gets down to production, the production worker just pushes the go button and watches the machine work. I've always been a generalist. I do it all. When I was working, I used to design mechanical systems, design the computer circuit board that controls them, then write all the software, test it, and train the users. And that's kind of what I'm doing on the NQALHA project. And I would argue that for small-scale projects where this kind of work is possible, boy, I get the insight and the continuity that you just don't get with larger teams of finely focused specialists. So that portion of the tool path is correct and optimized. And then I'm kind of carefully using the nozzle to avoid blowing the chip back into the hole, to just kind of like clear the chip off the tap. The spiral flute tap ejects the chip upward, and it's entirely possible that it would just run by itself if I didn't do anything, but I am just so nervous about tap breakage. So I'm going to load up the second operation here just to verify that it works before going into production. Typically, when I'm doing what I call my combo tool path, I'll have a set of parts in my hand that I'm deburring while the machine is running. So when the cycle completes, I have a deburred part ready to go, and I put a deburred part on the tooling plate, and I'm using, like I always do, I've got a precision pin turned on the lathe, just a, I don't know, 1/1000th undersize for a nice smooth slip fit. Got a little aluminum washer over there on the hold down screw so it doesn't booger up the aluminum. And I'm going to be trying this one for the first time. I got to be somewhat careful in designing the tool path that when I'm doing rapid moves, there's sufficient clearance with the tool tip. That looks good. That looks good. That looks good. Got to make sure that I have sufficient clearance so the rapids don't hit those protruding screws. So, with being extra careful there, this is using the aluminum shredder roughing cutter. 2 passes to go through 1/4 inch material, and then I finish up with the 3 flute 3/8 solid carbide finishing end mill, taking 15 thousandths for a finish pass. And yeah, there's probably, if I really cared, and I really wanted to speed up the operation, I could probably do it all with the 3/8 finish cutter with no finish pass, but you know, I really like my parts to look good. And the finish pass really does improve surface finish dramatically. So there we go. I'm going to put a Z move. Really nice that the machine controller has G-code editing. So yeah, I'm going to put in a move to unload position. And then I'm going to run a bunch of these guys, each in koala. Oh, and kind of not liking that very much. Good thing I didn't make too many blanks. I think I have an error in my setup sheet because that blank was a little too short. So I'm gonna go fix that problem. Here's what the part looks like. And yeah, little parts. Little parts take a long time to make. Nothing is fast in this business. Good thing I didn't make a whole lot of blanks, and good thing it's only 1/4" aluminum, but setup sheet's wrong. So I'm probably gonna make another couple of little parts today, so this may be a 2-part video. Oh, how exciting. So I'm going to turn the camera off, correct the error in the blank cutting, run a batch, and probably have enough time to make another part. Who knows? I finished optimizing the tool path as well as I'm going to optimize. Yeah, there's a couple of places where I might save a half a second here and there, but it really isn't worth it. So I optimized the tool path, corrected the errors, got the blank size correct, got all the blanks cut and deburred on the Scotch-Brite, and now here is the complete operation of combo, 4 parts at a time. Are you ready for some real machining excitement? The aluminum shredder. There's a chance I could do that guy in one pass. It's not doing a deep groove. It's mostly machining edges, and so chip evacuation really isn't a problem. And I'm looking over at the spindle meter, and I think I still have a little more spindle power available, but you know, I'm going to stop dicking with this one. I could drive myself crazy trying to shave off another fraction of a second here and there. If I was making 10,000 of them, yeah, I'd probably do it. But each koala requires 2 of these, so I need to make 20 of them. But they go pretty fast once they're set up and the tool path has been debugged and troubleshot, and errors have been corrected. So I'm doing the second operation first, and this way I can avoid a tool change when rapiding over to use the the 3-flute 3/8 finish mill to cut the bosses in the relief. Probably could optimize out that little Z move, but like I said, I'm done optimizing. I'm in production. Tool changer has been operating very reliably. No problem. I'm still waiting for my shipment of nylon screws because every time the tool changer misbehaves, it breaks 2 of the little nylon screws. And of course, that was the design. The little nylon screws are sacrificial parts that were designed to prevent damage to the machine when the machine goes crazy, because the designers knew that the design was right on the edge of not working. So I'm currently running with a 9-tool changer. The 10th position is out of service until I get my screws, and as soon as the 10th position is available again, then I can do the controller housing, which is the most complex part, most complex and longest cycle time of any of the parts in the project. So coming soon. And I like to have the tap operation be the last operation in the series, so I can blow off the coolant, lower the enclosure door, reach over and apply the magic, and it is magic. It's an amazing cutting lubricant. Now that one, the chips just fell right off. Sometimes they do, sometimes they don't. Fell right off. I put some of the tap magic on the tap itself to try to encourage the chips to fall off instead of wadding up on in the flutes. And hey, will you look at that? They all just fell off. Machine moves to unload position. Let me pick up one of the little guys down here and show him on camera. That's what it looks like. All is well. I'm in production. And I'm not sure if I'll do another part today or not, but if I don't, thanks for watching. If I do, there's more to come. All 20 of the previous little parts have been successfully made, and I got plenty of time, so I think I'll make 20 more small and somewhat simple parts. Just in case anybody cares, there was a bit of good news today. The UPS truck arrived together with, get it in the camera, together with a big bag of screws to repair the automatic tool changer. This is the fork, and there's the screw that holds it in place. These were somewhat challenging screws to find. They're nylon metric, and fortunately McMaster-Carr had them in Omaha. They didn't have them in Sacramento, so I had to wait a little longer. But so now I should be able to repair the tool changer and then tomorrow do the controller housing, which, as I said before, is the most complex part, the longest tool cycle, and takes all 10 tools in the tool carousel. So this part is similar but not identical to previous parts. It starts out with a blank in the right vise and then moves over to the left vise to machine the profile on the tooling plate. but because of the way the part is clamped onto the tooling plate, I've got clamping screws going through two directions just because of the geometry of the part, and there's a lot of details that influence that. So I actually made two tooling plates. And so I'm going to, instead of having the tooling plate in the vise and then screwing before machining, I'm going to have one over on the prep table so I can deburr the part, screw it to the tooling plate, and then when the time comes in the combo operation, just move the entire thing into the left vise. So once again, this is a known trusted tool path, but I'm going to treat it like it's new because it hasn't been run before today. I'm going to start out using the Tormach fly cutter because, as I said on the previous part, the aluminum extrusion, it's really close to dimension, but even if it was precisely on 375, this 3/8 material, even if it was precisely on 375, that wouldn't work because a 375 shoulder screw tightened down nice and tight, and then the part would bind. This is the arm that holds the other little parts that I just made, which are the bogies, and the arm and the bogies both need to rotate real freely on their kind of shoulder screw axles. So the first operation I'm going to do is to take the fly cutter and just kind of skin the surface, take it down a few thou. I'm referencing from the bottom surface of the part, which is kind of convenient because I've already set up Z0 on the ledge of the soft jaws, and it's always nice to, get another setup for free without having to make a new setup. So I'm ready to go here. I'm going to have, as usual, finger on the stop button, running single step. And actually, maybe it's not going to run the fly cutter first. Kind of thought it was. Memory is faulty. So, 1/4 inch hole, nicely drilled. This will be the hole that the shoulder screw goes through. So I guess I am going to be drilling first, and then either that or there's something wrong with the tool path, but we'll see. There might be something wrong with the tool path. Do a feed hold here and look at the G code. Well, okay. I guess this really isn't wrong to do the fly cut last, but I kind of like doing the tap operation last, so I may go. Come on. Touchscreen is, sometimes it works, sometimes it don't. 1024 tapped hole. Everything looks nice. Go back in the CAD room. Rearrange the machining order. Notice that the coolant is turned off on the fly cutter. Give you 3 guesses why. Fly cutter makes a beautiful, since I'm just barely skinning off a few thousandths. I really don't need the coolant. Fly cutter does an absolutely beautiful surface finish. But yeah, there'd be coolant all over everywhere if I turned the coolant on with that guy, with that effectively an airplane propeller. Now that is also a mistake. So that's so much for known trusted tool paths. Creating tool paths for NC machining is really similar to writing software. I spent most of my engineering career writing software, and I tell people software is easy. Every single little step taken in isolation is easy. It's trivially easy. It's so easy even a machine can do it. Problem is, there's lots of steps. You got to get them all right. Let's see if it's right this time. My toolpath program, Bobcad, sometimes just decides to change machining order for no good reason. Even though I specify a machining order, sometimes it just decides, oh no, I'm going to change it. So there's oh, that looks like such a beautiful finish. I'm preparing now using my hand tools because I'm holding the part in my hand and I don't want to have the thing ripped out of my hand by the very aggressive electric tool. So I've now got, you can see that there's screws going in from two directions on the tooling plate, so this guy is now ready for its second operation. Once again, hand applying Tap Magic. Tapping lubricant, Tap Magic for aluminum, really is magic, really works exceptionally well. So there, this completes the testing of the first operation. So let me deburr a blank here. And since I'm taking the tooling plate out every time, I have to be kind of careful and pay attention to the chamfered corner as the X and Y zero reference. I'll probably put a move to unload position too in the combo. So let's load up 231. I'm also notating cycle time because I keep records of everything. That I try to, or at least I try to keep records of everything, because keeping the project under control is really important. and you can't have too much documentation. You can't write down too much stuff in a project like this, because it is so easy. It's somewhere between 6 months, 8 months, a year in between production runs, and I go and do other things and just forget all the secrets. So okay, we're moving to the correct work offset. And coolant off. That is looking sane. Always got to be careful when dealing with a protruding clamping screw. (5140 RPM, 30 inches per minute. Doing it in 3 passes. I believe in my other parts I'm feeding at 40 inches per minute, so I'll probably go and change that in the toolpath program. But other than the feed being a little slow, things are going really well. No chatter. Using the aluminum shredder, which produces very, very fine chips that evacuate very nicely out of the slot being cut. Okay, on to the finish pass. Even though it involves a tool change that seems to take forever, I do change to the finish cutter because cutters are expensive, and I'd rather have my roughing cutter take all the abuse. Makes my finish cutter produce a nice surface finish for a little while longer. So that is a correct second operation. Now let's make sure that the first operation is still working correctly when combined into a combo. Each NQALHA uses 2 of these, so I need to make 20. And that's interesting that I've got a little bit of lubricant, a little bit of coolant on the surface left over from the previous operation. So maybe that actually helps a tiny bit, although that surface finish is just so beautiful, you can't argue with it. It's looking like, except for one little adjustment, the combo toolpath is completely correct. (2500 RPM, 10 inches per minute, fast pack. I believe it's about 80 thousandths per peck. 1/4 inch drill. A 1/4 inch nominal drill produces a nice, clean slip fit on the shaft of a 1/4 inch shoulder screw, so there's no need to use like a 1,000th oversized reamer or something. the hole produces a very, very nice, smooth slip fit. And there we have it. Very, very close to correct. I'm probably going to also add a move to the unload position. So let me slowly and manually here, because I just don't like hand holding things and using the electric and screwifier. Too easy to have it just jerked out of my hand. So there's the part. Let me get the pretty face up. There's the part. All is well. Everything's under control. Thank you for watching. It's been fun.